everyone. Let's go ahead and get started. Thank you for attending the summer edition of 5G Blitz Week. My name is Kevin Gray, publisher of Fierce Wireless, and I will be your host for today. Before we get started, I'd just like to thank the sponsors for today, including NokiWave, Samsung, and Zenfi Networks. Today's session is titled The Future of Millimeter Wave, Technology, ROI, and Beyond. And so you can best prepare yourself for today's sessions. Here's a quick schedule of events. From 11 to 11:15, we're going to kick things off with a keynote interview with Chet Kanoja from Starry. From 11:15 to 11:30, we're going to have a sponsored keynote from NokiWave's Abhishek Kapoor. And from 11:30 to 12:15, we'll have our main panel with speakers from Orange, Zenfi, NYU Wireless, and Samsung. And time permitting, we will follow the panel with a Q&A session, so please submit your questions using the Q&A tab on the left side of your screen. Okay, that's pretty much it. Let's go ahead and begin. I'm going to pass things over to the Managing Director of Mobile Ecosystem, Mark Lowenstein, who's going to kick things off with Chet from Starry. Mark, please take it away.
All right. Good morning, everybody, and very happy to be with you on day 3. The first 2 days of 5G Blitz Week have been terrific, and it's great to have an opportunity to focus now on millimeter wave for the next 1.25 hours. We're going to kick it off with a fireside chat virtually with Chet Kanoja, who's the co-founder and CEO of Starry. I've known Chet, and I've known back to the Aereo era. I was actually a customer of Aereo a number of years ago. And it's been great to follow the progress of Starry, which has been looking to disrupt the traditional broadband universe and has been a pioneer in the area of fixed wireless access. So welcome, Chet. We're both coming to you today from Boston. So why don't we start off with for everybody just a quick introduction to Starry, what you guys do, and sort of where you are today with the build out of your fixed wireless networks.
Thank you. Starry is a fixed wireless operator and a technology producer. So we design and manufacture our own sort of tech stack that includes data interfaces. We actually end up doing some ICs as well, and manufacture our equipment, and then we operate the network, build out and operate the network ourselves. We are today deployed and live in 5 cities, so Boston, Los Angeles, DC, Denver, and New York, and in various stages. Boston's probably the most mature deployment. Continuing to grow the network and then sort of planning out the next phase for the company's growth. I think we've been relatively open about some of our plans where we intend to end this year with about, give or take, 8 to 9 million homes under coverage. And then we have 24 gigahertz spectrum that is in about 110 cities, about 53 PEAs. So that's a big build out project coming up for us. Yeah.
Are you still using the 28 gigahertz spectrum that you had on the sort of initial experimental license, or is it now all at 24?
No, we never had 28.
Okay.
We were operating in what's called a lower 37, which is the coordinated point to multi-point sharing band. It's fully licensed, so we continue to use it, and we will continue to use that and as sort of a multi-band strategy for the company.
Yeah, and so just take us quickly through what the elements of a Starry solution are from the standpoint of building it out, in a market, and then from the standpoint of the customer, because I know you make your own, for example, the CPE that goes in a household or in an MDU.
Yeah, so we look a little different than what I would say traditional millimeter wave deployments. Right. Starting with the basic technology, we're not 3GPP based. We're IEEE standards based approach. So we use 11AX as our basic radio strategy, and then we heterodyne that into high power licensed spectrum. Most of our base stations are, it's multi-sector implementations. They run 8x8 multi-user MIMO as a start, spanning 200 megahertz channels. So it's a fairly really high capacity approach that we've taken. We're also very different than most approaches because we tend to use altitude. So we look a little bit more like a satellite system, if you will, than a traditional uh, millimeter wave deployment. And what I mean by that is we tend to use pre-existing macro sites to a large extent. So we work with SBA, Crown, ATC, all the sort of usual suppliers in the area. And it's a fairly dense fiber network. So we, our sites are fiber fed and tend to have a fairly large coverage area just because we are using altitude as well as high power. And then basically go out and put receivers, transceivers on high altitude points on homes or buildings, and then typically tap into pre-existing wiring inside the premises. And then we also supply our own Wi-Fi device to the consumer.
And you are primarily targeting MDUs, multiple dwelling units, correct? Less so sort of individual homes?
We started that way just because our electronics costs weren't down enough. We are actually in the midst of now rolling out our next generation small form factor radio that is targeted at single families and brownstones and things like that. So it's the same basic capability. They all are 2x2 MU-MIMO receivers. And so they have, good 1.6, 1.7 gigabits worth of capacity at 160 megahertz channels. And so those are just getting rolled out now. They're in trial phases. And so increases our TAM, if you will, from just MDUs, which was historically kind of where we were for the last 2 years, to single family and small, multi-tenant type situations as well.
Right, and that's going to go into your existing markets and to existing neighborhoods where you've built, correct?
Exactly. So as we've been densifying the network, and typically, if you think about the total TAM, first phase for us was just 60, 70 units in greater buildings. Now we're adding one to any size in there. So big ramp coming up for us.
And you've been in a few markets, I think, especially Boston, LA, and DC for at least a year or two. And I'd be curious, for markets where you've been in for a little while, what have you been seeing in terms of usage patterns, and how does that compare to a traditional fixed broadband user, or maybe at the other end a traditional mobile user?
Yeah, so it sort of tends to exceed a fixed broadband user just because by default our customers are cord cutters. So all the video that they're consuming is all over the top. And they tend to be a little bit more, technologically sort of aware folks. So, it tends to be more 4K video or gaming. Our typical customer today is probably approaching mid 400 gigs a month on average. And the top 20% probably like 700-ish gigs, and we have a few that exceed 1.3, 1.4 terabytes. So slightly north of the fixed broadband. So obviously not even a comparison to the mobile side. And what else is interesting? Yeah, and we have a symmetrical network in for the most part. So we see a fairly robust uplink consumption as well. So we used to have, typically 10-to-1 ratio used to be the norm for us, down to up, and that's now become more like 5-to-1. And
really? Okay.
Yeah, so it's a pretty high utilization on the return channel side as well. And I believe we're the first ones and still the only ones that are doing full TDD in millimeter wave. So it's not a frequency uplink.
Right. And certainly a lot of questions that I get about Starry, and I'm sure you get the same ones, are how are you able to support that level of capacity utilization? And my recollection is there are no data caps. This is an unlimited plan. that
Right.
you're offering, and you've been that way since day one, and you've been continuing as the network's gotten more loaded in cities. So how are you able to pull that off?
Well, if you think about it, right, if you're running 200 megahertz and if you're running a 8 by 8 multi-user MIMO system, right, you're getting a lot of spectral reuse, and then that's on a single sector. So then, you're running probably 6 to 8 sectors side by, throughout for forming a full 360-degree coverage area. So most of our sites are 40 gig sites today. So that's, equivalent if you were to compare to cable. I don't think most cable companies are even remotely close to 2 or 5 gig nodes. And so, you've got, we're running 10 to 20 times the capacity on a per site basis today. And that, we can continue to improve and increase that obviously as new standards emerge. You can bond greater channels, go from 160 to 320 megahertz channels. And so lots of, and greater spectral reuse, spatial reuse of spectrum as well. So a lot of it is, basically using what you would call, available technologies, massive MIMO and large channel sizes being sort of the primary one of them. And then we do a lot of proprietary work in beamforming on the passive side as well. That allows us to be a lot more efficient about interference and things like that.
Okay. And since you're mainly in cities, let's talk just for a minute about how Starry compares to the other fixed wireless rollouts occurring in cities. So not the WISPs, but some services like Verizon's 5G Home, and maybe even what T-Mobile has talked about with regards to its fixed wireless deployment as part of the Sprint deal. But I guess 5G Home is the main one that actually competes with you in a couple of cities.
Yeah, I think in theory it does. We don't see them in reality. It's my sense is, sitting from a distance, they're trying to solve a very different problem, right? They're trying to solve a mobile problem first and a fixed mobile combined problem. So it's a very different style of network, much harder lift, if you will. We're sort of cheating in a way, right? Because we're kind of operating almost as a satellite, right? So you've got high altitude points that are just blasting power down, and with very little obstruction to a large extent. We have sufficient power. We do deploy in situations where we call it NLOS with a small n, near line of sight, and that means we'll have sufficient margin for one or two trees. And so we're not really trying to solve we don't think modern construction material you're really going to effectively solve a penetration problem with anything in millimeter wave or even centimeter wave for that matter. So we basically take the practical approach, which is, look, use altitude, use pre-existing macros. Yes, you have to do an install, and it's not that big a deal when you sort of solve all the problems the right way.
Okay. I know we're quickly running up. 15 minutes goes fast in one of these things. We could be on the phone or on this for a while longer. But I guess one last question I want to ask you is what has been sort of the effect of COVID so far for you? I guess as a business, and also what you're seeing in terms of customer take up and usage patterns. Has there been sort of notable change as a result of what we've been dealing with for the past 6 months?
Has gone up, 30-40% on downlinks, has gone up 50%
Really?
on the uplinks. So obviously, everybody's seeing sort of similar patterns.
Yeah.
Take rate hasn't really changed. I mean, I think Q2 for us was sort of the largest quarter growth-wise. We've been continuing to grow 10-15% a month throughout this Q1 and Q2. So we see, secularly, it's a good, the pandemic's not good, but the fact that people have to now continue to live their lives at home and do all the other things that they needed to, it's good for business in that sense.
And how during this period, how have you been selling into the markets? I know, historically you've done a lot of, literally door to door. It's been a lot of sort of in-person type model in terms of sales. So
yeah, less so. It's been more digital, but along with sort of what I will call analog, collateral.
Right.
But it's we had to transition away from sort of the field marketing that we mostly did for subscriber access to more digital. and our penetration rates
Yeah.
haven't really changed.
Right.
So we,
Right. No, I know at least in my town of Brookline, and you're not offering service in all of Brookline, but we certainly see the starry trucks, and you see you in all the buildings, with the collateral, and I've seen people park, pre-COVID actually parked outside of buildings and setting up, temporary, desks for people when they're coming in. So anyway, it's been good. So it's a good traditional model. So I think that's. Oh, I had one quick audience question. So both 24 and 34 and 37 gigahertz were mentioned. The 5 cities that you called out, are those 24 only at this point, or is it both?
they're 37. 24 starts for us probably Q4.
Okay. And last question, then we'll have to go. Would you consider, this is from another person in the audience, would you consider using a 3GPP based 5G in the future, or do you really see it, you're going to stay with the proprietary solution that you have today?
We have no religion. We
Okay.
basically work off of unit economics. So if somebody can paint a path, and especially 5G NR standalone, can get us a path towards $200, which is what we're doing today, $200 to $300 STAs. We'd be happy to consider that.
Okay, great. Well, this has been great. We've covered quite a bit of ground in 16 minutes. Really appreciate you participating, and wishing you the best of success for the rest of the year and continued rollouts. And I guess at this point, I will hand it back to Kevin.
Thank you.
Great. Okay. Thank you, Mark. And thank you, chat. Always interesting to see what Starry is up to. Next up, we have our sponsor keynote from Anokiway's Abhishek Kapoor, who is their VP of Global Sales. Abhishek, please take it away.
Thank you very much for the opportunity. Good morning, everyone. This is Abhishek Kapoor, Vice President of Sales at Anokiway. And today we are here to talk about how we can enable millimeter wave 5G systems today. So for the last several years, there has been big discussion about whether millimeter wave 5G is going to become a reality or not. And I think that question has become kind of antiquated, and it's more about how successful and how ubiquitous millimeter wave 5G can get today. And in the presentation today, we'll be talking about some of the common challenges that the industry faces, what are the solutions that are being offered, what role Anokiwave as a company is playing in this, and making this a commercial reality today. Before I get started on the presentation, I wanted to spend a minute giving an introduction about who Anokiwave is, so everyone has some context about what forms our opinion or the perspective from which we are presenting this. So Anokiwave is a fabless semiconductor IC company, and we provide silicon core ICs that are used to build active antennas or phased array antennas for 5G, SATCOM, and radar markets. We have been providing silicon core ICs already for the 3+ years that are used in 5G millimeter wave systems in US as well as other places across the globe. So we are close to the whole deployment of millimeter wave 5G. We understand the customer expectations, challenges, and where the market is headed. And based on that, we are presenting what are some of the common challenges and solutions to that. So with that said, if we go to the next slide, for a successful and ubiquitous deployment of millimeter wave 5G, we think it boils down to 4 key things, which are system level thinking, solving commercial and technical challenges, and third and fourth, I'll merge those together, and that comes down to breaking some of the traditional biases and embracing disruption. So I'll go through each one of them one by one. Talking about system level thinking, as we all know, going from 4G to 5G is a complete overhaul of technology, the wireless systems, the way the economic or business models are going to work. Everything is new, and this requires a complete system level view for every entity involved in the deployment of millimeter wave 5G. An entire network, and we'll talk about this in the next slide, starting from the user equipment, fixed base stations, fixed wireless access, macro base stations, picocells, repeaters, everything has to be deployed with new architectures. And it's not an incremental change that we have traditionally seen for the last couple of decades, going from 1G to 2G to 3G and so on. And it is important to think about the system level view. Now, as we think about the system level view, there are some major technical challenges just with the physics of millimeter wave and the technology choices, plus some commercial challenges that have to be solved. And this could be in time to market, the cost of the hardware, the manufacturability of the radios, and so on. As we all know, in the millimeter wave 5G world, the volumes that we are talking about, even on the infrastructure side, is orders of magnitude higher than what we have traditionally seen in 3G, 4G, and other fast wireless technologies. So a different kind of manufacturing supply chain, different kind of design techniques are needed, and that's what Anoki Wave is enabling today, and we'll talk about how we do that in this presentation. The key thing I'll focus on is time to market. And as I said before, the question about whether millimeter wave 5G will happen is a bit outdated. It's more about how fast it's going to happen. There is a clear need from the operators. There is a clear need from the market. And the question is, what can companies like Anoki Wave and others do and are doing to make this time to market quicker? And then going to a mindset change as we go into the 5G world. It's about breaking some of the traditional paradigms. As we have seen in most disruptive markets or most innovation markets, the innovation leaders are typically not the traditional established players. Up until 4G, the market was led maybe on the semiconductor side, the OEM side, and other places by some of the established key players. Now, the general assumption that these same key established players are going to lead the technology innovation, the business innovation, make millimeter wave 5G may be too much of an assumption to make 5G a commercial reality. As you can already see in terms of technologies that are being offered, the innovation is being led by the smaller companies, and we just have to embrace this fact, embrace these innovations, embrace these new entrants. The technology choices are different. Like you're going from a traditional sub-6 gigahertz architecture to a millimeter wave phased array architecture, which is a lot different technically and commercially. And those have to be embraced as to make millimeter wave 5G a commercial reality. The good news is that Anoki Wave is already doing that today, and we already have ICs available today to make millimeter wave a commercial reality. We have been not just offering, but rather providing in high volume these ICs for the last 3+ years, and a large portion of the 5G radios in millimeter wave deployed in US and other places worldwide are powered by Anoki Wave ICs. And that's largely because we are trying to address all these 4 things. Think about system level view, address every band of millimeter wave 5G, solve technical and commercial challenges, and more importantly, don't assume that just the traditional established market leaders are going to lead this entire market into the new era of millimeter wave 5G. So with that said, just going into the system level view. So this is a picture that shows what needs to happen for millimeter wave 5G to be enabled, this entire ecosystem to happen. Traditionally, on the very left side is your infrastructure or high power base stations, and on the very right are very low power, small form factor UV type equipment. And in the sub-6 gigahertz range, those were the 2 entities where the market focused on. As we know, the physics of millimeter wave is different, and there is a new, group of devices that also has a very important role to play to provide ubiquitous coverage. And we call these network enhancers that also have to be developed. And these are like the picocells, the repeaters, the indoor and outdoor CPEs, and variations of these that have to be deployed. What this means is that not only do you have to install an infrastructure devices, but you also have to provide these network enhancers and UEs to make entire millimeter wave 5G possible. So that's a lot of devices across multiple different millimeter wave 5G bands in multiple different geographies. And to make this a reality and make the ROI justifiable for carriers, it has to be done quick enough. So what that requires is the OEMs need high performance devices today, not tomorrow, not day after tomorrow, not a year from now, but today. They need scalable designs that can be very quickly scaled from one frequency to another frequency without having to redesign, and across various radio types, high power to low power to really low power. And then coming onto the commercial side, there is a need for making these radios manufacturable at a much larger scale than we have ever seen before, especially on the infrastructure side. The volumes, as we all know, even on the infrastructure side in millimeter wave 5G, is orders of magnitude higher than what we have seen in the past. And with the new phased array technology being the underlying baseline for this, there has to be manufacturability built in these designs that these can be done at an extremely high volume. And then more importantly, the cost of the individual components also has to be low enough that the ROI can be justified for the operators. And this is what Anoki Wave, as an IC provider that's already delivering the 5G promise, is doing that. Going a step further into the details of some of the challenges that the market faces and what's required, one of the biggest challenges the operators face today is slow time to market. And this could be because of the lack of technical options in the market, or at least the perceived lack of technical options, limited millimeter wave experience, going from sub 6 gigahertz to millimeter wave. All the skill set and experience that you need is much different. And that all slows the whole deployment of millimeter wave 5G. What's required are production-ready parts today. And you need IC solutions across all millimeter wave 5G bands, not one, not two, but all 3 to 4, and even the newer bands, with scalability across all these solutions. So you don't have to redo a design every time you have to address the need of a new operator, new geography, and so on. Cost, as I mentioned before, is even more critical than ever before, not just because the volumes are higher, but also because the manufacturability is key, especially as you get into the phased array active antenna architectures. How Anoki Wave is solving this problem is what we call bringing the handset IC technology based on silicon CMOS processes into the infrastructure world. That's almost redefining the ways ICs are used in the infrastructure world, and bringing the high volume technology and bringing the cost down even for infrastructure. The physics of millimeter wave has been a big concern for a lot of folks, and that actually led to a lot of debates for the last couple of years about whether millimeter wave is going to happen, because the coverage footprint of every base station is small. But as we have done with more than 3 generations of ICs already, with a year-over-year improvement, we are able to improve the radio performance and address this issue by increasing the range every year. And those cycles of learning are very key. And that's where it's important to work with companies that are leading the innovation curve, going through those cycles of learning quicker than anyone else in the market. And then power dissipation, again, one of the technical issues, but that translates to large form factor, bulky radios, more expensive radios, which operators don't like. And again, that's being addressed technically by Anoki Wave, by higher power efficiency and better performing devices already being provided and deployed in the field. So just comparing what the world looked yesterday versus the world looks today with millimeter wave 5G. As you can see on the left side, it was the world of traditional established players continuing to do incremental improvements. The new world requires new entrants leading the innovation curve. And this innovation is on the semiconductor side, on the system integrator side, OEM side, and even on the operator side, we are seeing that influx. The traditional sub-6 gigahertz architectures were very well defined. The whole goal was keep increasing the number of channels or per IC and keep integrating stuff, and that basically leads to a lower cost design. On the millimeter wave 5G, it's a complete rethink of that design, and you need an entire new type of skill set where just integrating more stuff does not reduce your cost, but you have to think about things outside of that, like calibration, which makes manufacturability much easier and much quicker if you remove that step. Similarly, the infrastructure world in the traditional 2G, 3G, 4G was considered slow, lower volume, limited number of devices. The new world is lot higher volume, lot quicker, lot more aggressive pricing, which requires CMOS-based IC technologies, including like the SOI technology, which is handset technology, being brought into the commercial infrastructure world. So it's going into how Anoki as a company is playing a role in making millimeter wave 5G a reality today. What we say is we are delivering the reality today. It's not a promise we are making for 1 quarter from now, 1 year from now, and so on. We're already doing this for the last 3+ years. We have been delivering the highest performance ICs in the market today, and large portion of the US and worldwide millimeter wave 5G radios already use Anoki Wave's ICs. And so the proven reliability is known and well respected. And then the cost in terms of year-over-year improvement, we have reduced and offered more than 95% cost reduction by going through these year-over-year cycles of learning and new generation of devices that we produce. Today, Anoki Wave is solving the problem for OEMs and operators in every band of millimeter wave 5G with solutions for N257, 258, all the way up to N261. We have 3 generations of devices, all in fielded use across different operators. Some of the neat features like zero calibration completely changes the way phased array active antennas are designed by using Anoki Wave IC technology, where you completely eliminate the need for any calibration required in your arrays, thereby speeding up your whole manufacturing process. And then, of course, as we talked about, the 95% cost reduction, that's key to making the ROI justifiable for the operators as they deploy these millimeter wave 5G systems. This is just a quick snapshot view of all the different use cases that Anoki Wave is enabling today using its millimeter wave 5G ICs. This is all done using the scalable designs that you can go from low power to high power and so on. So in summary, the OEMs, operators, and other industry players need to embrace that the innovations and the realities of millimeter wave 5G not necessarily are going to be led by the traditional established players, and there are solutions that already exist. Anoki Wave is one of those players which has production ICs with silicon ICs available today and globally, enabling the millimeter wave 5G reality. And look forward to speaking to you all. Thank you very much.
Okay, thank you, Abhishek. Now let's go ahead and move things over to our main panel with speakers from Orange, Zenfi, NYU Wireless, and Samsung. And for this, I'm going to go ahead and pass things back over to Mark from Mobile Ecosystem. Mark, please go ahead.
All right, thank you, Kevin, and good morning, everybody. Welcome to this panel on millimeter wave. We've got a good session. This is a continuing rapid fire. No time to walk into the hallway and grab a coffee and a cookie or anything like that. So I wanted to just talk quickly about the format of this session. We have 45 minutes. I'm going to just quickly introduce the speakers, and then we're going to have each of the speakers just do a couple of minute quick introduction to their firm and what they're doing in the area of millimeter wave, and maybe a couple of top line thoughts, and then we're going to launch into a roundtable Q&A. I'll start each question by asking a particular panelist to kick things off with an answer, and then I would ask the panelists if they'd like to also contribute to that question or had a comment they wanted to add, if they could just sort of raise a hand just so I know to call on you. That's just sort of the best way to work with this this technology and the latency. So let me just quickly introduce our panel. We've got Yves Belejo, who is the Director of Network Strategy for Orange, Andy Penley, VP of Wireless Solutions for Zenfi Networks, Ted Rappaport, who's founder and director of NYU Wireless, and they do a wonderful 5G conference annually themselves every year that I've had the privilege of attending, and Alok Shah, who is VP of Network Strategy for Business Development and Marketing for Samsung, and then Abhishek from Anoki Wave will join us for the roundtable for some of the questions. So why don't we just quickly kick off with each speaker taking just a couple of minutes. Eve, do you want to start us off?
Yes. Hello. Good morning, everyone. So I work in Orange on the network strategy. At Orange, we are mobile operator. So mainly today we have customers on 4G networks. We are also a fixed operator. We have customers on copper, on fiber. Our markets are mainly Europe, both Western Europe and Eastern Europe, and Africa, Middle East. So, in fact, the main question I'm working on is where shall we invest in our networks in the coming months, in the coming years? And on 5G, and especially on millimeter waves, at the moment, we have two main targets. And those two main targets that we have been working for now some time are the fixed wireless access case. So we have been doing trials back in 2018. Now we are preparing the next step, which is more larger scale trials. And that is typically the case to complement all what we are deploying on fiber, because most our investment today is deploying fiber in our networks in Western and Eastern Europe. And the other big case we are working on millimeter waves is to get that embedded into the smartphones so that can be used, especially in heavy loaded locations. So we are doing different trials. We have one trial, for example, which is a railway station. So typically we are testing with the customers that they have very fast download, typically of movies on their smartphones, and also the use of 5G services based on millimeter waves by the for professional services by the people of the railway company. So these are the first two cases in a summary that we are developing at the moment on the 5G European bands millimeter waves.
And if I could just ask a quick follow-up question on that, which of your countries are you able to do millimeter wave in? Are you licensed?
In fact, what we did initially back in 2018 was a test in Romania, fixed wireless access. That was a trial license. Today, we have also different trial licenses in France, where we are doing, for example, the railway station I mentioned is in a city in France. We have another location also where we have a trial license in France. That are the main cases today. In most of our European countries, we do not have commercial licenses. So we just have trial licenses.
I see. Okay. Thank you. Okay. Andy, Zenfi.
Good morning. Zenfi has a pervasive C-RAN infrastructure in New York and northern New Jersey. We own and operate a fiber network. We couple that with thousands of vertical siding solutions and densely deployed micro edge data centers. I would say that we've been preparing for millimeter for years now with the support of mobile densification throughout New York and New Jersey. We have thousands of sites existing in the right of way. We are under contract.
I'm afraid we might have lost Andy, the audio. Andy, are you able to hear me?
Yes.
Okay, I think we lost you about 10 seconds ago. Why don't you just pick right up back up?
Okay, I'm sorry. Looks like maybe I'm a little unstable. A lot of latency too. I'm not sure where you guys lost us, but Zenfi has been deploying sites in the right of way in support of mobile densification for years. And now we're starting to see municipalities consider allowing form factors that would support millimeter wave to be added to these thousands of vertical siding locations. So we've been involved in the deployment of millimeter wave infrastructure for quite some time now.
And are you building this for the mobile operators who have millimeter wave licenses in New York and New Jersey?
Yes. So we take the view that all this infrastructure, including the siding, the fiber network, the hubs, the only way this works from a capital perspective and from the finite resources available is that it's all neutral host, right? So we own and operate everything we build, and we do long-term leases with multiple MNOs across this infrastructure. We view our network just like a horizontal tower. So we have these the base station hotels, which would be like your hut at the bottom of the tower. We have this large fiber network, which would be just like the cables running up the tower, and these thousands of vertical siding solutions, which would be just like the antenna locations on the tower.
Okay, great, thank you. Okay, Ted Rappaport, good morning. Take it away.
Good morning, Mark. Are you able to hear me okay?
Yeah, great.
All right, thanks. And thank you, Mark, and everyone else on the panel. Pleasure to be here. I'm Ted Rappaport with NYU Wireless, a faculty member there, and founded the center in 2012. There in New York and Manhattan, we led some of the work that proved to the world that millimeter wave could work and work better than conventional first 4 generations of cellular. Now, that's been a controversial statement over the last 7 years, but as more and more engineers, including those on this call and the panel, have seen that millimeter wave actually can work better when you use adaptive antennas, highly directional, steerable, electrical steerable antennas at both the base station and mobile equipment, as we heard on the Nokia Wave keynote. NYU Wireless has 16 of the largest companies in the world focused on developing 5G and millimeter wave technologies on the continents of Asia, Europe, and the US. In fact, Samsung is one of our 16 board members at NYU Wireless. We have about 100 graduate students, mostly PhD, and probably 1/3 master, 2/3 PhD, and several undergraduates, all focusing on wireless communications, looking at 5G and 6G, moving to frequencies well above 95 gigahertz, which is our current focus, as well as artificial intelligence, robotic applications of wireless, information theory, and circuit design. We have a number of open source products that NYU Wireless has developed for the industry, and many of the companies involved here and on our board and throughout the ecosystem are using them, for example, to model the radio propagation characteristics, the end-to-end network performance, and other aspects of building out 5G wireless. And in this panel, I look forward to sharing some of the insights and observations that we've had in this 7-year journey to proving that millimeter wave can work and what capacity capabilities are, and surprisingly, what some of the real world issues are in implementing the technology. Thank you.
Mark, we can't hear you. Were you on mute?
My apologies. Ted, thank you very much. There was a garbage truck going by, so I decided to mute for a second. Okay, so Alok from Samsung.
Yeah, thanks, Mark. Good morning, everyone. Samsung is a leader in 5G across sort of the end-to-end ecosystem, mobile devices, of course, network equipment, and even chips, where we build RF and modem ICs for our products, or for many of our products. Millimeter wave has been an area where we've really focused. Our 5G research activities started over a decade ago, actually in 2009. Published kind of the first early research papers in that millimeter wave category and for mobility in 2011 or so. Proof of concept systems in place 2013, and really have been very active in demonstrating key benchmarks on the path toward commercialization of millimeter wave 5G. We're, involved in Verizon's 5G home deployment in 2018, and in the commercial launches in Korea at the end of 2018 and 2019. So, really proud to be a part of the 5G ecosystem, and millimeter wave has really been an opportunity for us to grow our presence in the infrastructure market. Every generation is an opportunity to come in and win new business. And with 5G, and especially with millimeter wave, we've increased our presence in markets like Korea, Japan, the US, and Europe, where we've always been active. but also in new places like Canada and Oceania. So look forward to the discussion here today.
Okay, that's great. So I just wanted to get everybody up to date, who's listening in on this session in terms of where millimeter wave networks are commercially operational. We know in the U.S., but what are some of the other geographies? We know that millimeter wave has been licensed in a number of markets, but where is it commercially operational today in addition to the United States? Alok, do you want to just take that one for a sec?
Sure, happy to start. Obviously the U.S. has been the most aggressive in commercializing millimeter wave across 28 and 39 gigahertz, with more spectrum coming all the time. We have seen trial activities, as you've noted. There have been trial activities in various parts of Europe. There was use of millimeter wave in 2018 for the Olympics in Korea. But as far as commercialization, we expect, and the Korean operators have talked about millimeter wave coming to their networks around the end of this year. Japan is a market where 28 gigahertz has been commercialized to some degree. They just launched their 5G, a couple of months ago. So I think we'll see more and more millimeter wave in that market as well. I think Eve may be better to speak to the European market. There have certainly been licenses approved in certain locations, and we see some really interesting use cases around fixed wireless and other applications there.
Okay, that's great. The next question I was going to ask is, we're about 2 years into the launch of millimeter wave networks, particularly here in the U.S., and 1 year, especially sort of in earnest. And I guess I'd like to ask, what have we learned in this initial rollout phase so far from actual real use of the networks? And maybe Ted, you can start with that one.
Yeah, happy to answer that. The interesting thing is there was a lot of early bad press on some of the very early efforts by Verizon. I think Moffett put out a report that showed that it's pretty difficult if the antennas aren't put in the right space for the microcells, or there's a lot of foliage. And it is true that there's a lot more sensitivity to the foliage issues and placement of the infrastructure. But I think those are the kinds of things that in any technology rollout, the installers, the technicians in the field quickly get a handle on, and that's happening. The fact is that the path loss, the attenuation is much less. That is, there's much more coverage for a given amount of power for the massive bandwidth that you get when you use these adaptive antennas, which are being placed in the handsets, and even more importantly at the base stations. There are some practical issues, though, that people are finding. For example, in New York City, if you look at the zoning laws, you'll see that every facade of every major building in Manhattan, if it's more than 5 stories tall or so, has to have scaffolding installed once every 4 or 5 years to do a full inspection of the building, so the building doesn't crumble and things fall on pedestrians. So roughly 20% of every single building in Manhattan at any time of day will have scaffolding on it with metal, usually metal and not wood, certainly metal structure. That impacts the deployment of millimeter wave. So some of our industrial affiliate sponsors at NYU Wireless have had us look at and help provide statistical modeling to anticipate how coverage will be on the street level with scaffolding. So these kinds of new world issues are happening, and the engineers and technicians are dealing with it, but we'll solve it because of the remarkable adaptability in the equipment, the ability to finally put the RF energy where you want in space is really a game changer.
Who else would like to weigh in on that question? We know what we've sort of seen so far from millimeter wave in the commercial deployments. Anybody?
I'll note. Yeah, I think it's an important point that we're very much in the early innings of this, right? And I think some of the confusion around millimeter wave perhaps came from folks who sort of mistakenly viewed it as a potential coverage layer, right? And it was never really meant for that. It's meant to provide a boost in capacity in areas where you have a high population density, right? Quite simply. And so, I think for that purpose, what we're finding is that the deployments are going quite well. That the performance has been very good. But again, we're in the top of the first, maybe the bottom of the first inning when it comes to really getting enough transmission points out there to really to get kind of the experience that the operators are looking for.
Okay.
Yes, if I may.
Yves, did you have a comment? Yes.
Yes, in fact, I kind of the same comment. In fact, we have moved from the hype and some unrealistic statements, in fact, on both sides, whether it would never work or it would replace existing networks, to now more realistic view what one can be used. So millimeter waves will not replace typically the sub-6 gigahertz bands. So that's not at all something that is realistic. But there are a lot of different use cases where millimeter waves really bring benefits. And the good news for me is that we have a large variety of cases on fixed, on mobile, and that there is some traction to get the millimeter waves into the handset, the devices. That is very good news. So now the good news is we are now on real track for real use cases, not just hype, and that's a good point. So it will take time, but we are on the track.
Yeah, and again, as we're now in commercial markets and we're deploying more and more, I guess Andy, I'd ask, has there been any change in the way you're looking at doing some of your deployments from some of the learnings that you've had over the past 12 to 18 months?
Yeah. So, really there's like there's 3 steps in getting these deployed, right? There's building this really dense infrastructure to support it. And then the second step seems to be the one that's most difficult, and that's getting the municipalities, be it New York City or the smaller municipalities in the metro market, to approve the form factors. So we're fighting some battles we never had to fight before, or we didn't have to fight as much, such as informing the public that there's no incremental health risk associated with these deployments, and convincing them that the trade-off of the visual pollution that we're going to create, the trade-off of this high capacity broadband access that we're going to deliver, that is a good trade-off, right? And everybody has their own opinion about that. So the education of and the working with the municipalities is much more difficult than it was previously.
Okay, great.
If I might add,
yes,
that
please.
was one of the impetus by the FCC to do their small cell initiative, to try to put some federal pressure on the municipalities to allow rapid deployment of small cells, which is what 5G millimeter wave is. Because it's really a tax. It's really a cellular tax. The delay, the cost, the permitting, litigation, if carriers can't deploy the technology quickly. So there are a number of enlightened municipalities that have approved form factors, but it's been a very piecemeal effort. The FCC small cell initiative was meant to try to give a boost to accelerate the shot clock so that people could quickly get infrastructure on towers and on existing right-of-ways. It's not clear to me where we are at this very moment. I think there's been some progress, but there are also some big holdups by some major cities, from what I understand.
Yeah. I guess as a follow-up to that,
you have to be really.
Sorry, somebody else was commenting.
I apologize. I was going to comment on that. There's a ton of latency here. I apologize. That shot clock, you have to be pretty careful about how you utilize it, right? You have to work with these municipalities, in perpetuity to deploy more sites and continue to densify. And they certainly can make it very difficult on you. Even after you get municipal consent, generally you have to go back and get permits for every site. So it's certainly better to use the carrot than the stick, I think. I think the stick has to be, really long-term last resort if they're just not responding to you.
Yeah. Just as a quick follow-up to that point, I was going to ask a lot. Have you, as a result of COVID, are we seeing any delays in some of the permitting and for small cells? Has there been sort of any appreciable impact there, or is it pretty much sort of as it was, let's say pre-March?
Yeah, it's a good question, and of course, every municipality is a little bit different. But what we found for the most part is that the concerns we had kind of going into this have not really taken place. I think municipalities and operators have worked closely to figure out how to work around some of the challenges around, offices being closed, things like that. I don't think it's been easy necessarily, and there probably have been some, minor delays here and there. But for the most part, the operators continue to deploy pretty aggressively. I guess the one factor to consider is that that process takes some time, and so some of the sites that were coming through the process during the pandemic period had already been in the pipeline, right? And so we might see some delays down the road, perhaps as the pipeline delays eventually manifest. But so far, it seems like it's been pretty smooth.
Yeah, and one positive thing I've observed is that for the most part, we have not really seen any operators, with any appreciable scaling back of their commitments to build out or a trimming of capex. We really haven't seen that yet, so that's encouraging. All right, so my next question, I just wanted to focus for a couple of minutes on where is some of the thrust of innovation going on right now in millimeter wave? Again, been in the markets for a couple of years commercially. There's lots of trials going on, so that's spurring, and we're learning a lot. So, what are some of the areas where there's a focus on improvement, focus on innovation, and maybe we can work in a comment or two about some of the improvements that we'll see as a result of the of 3GPP R16. Ted, do you want to start us off on that one?
Yeah, happy to. Well, Nokia Wave's talk gave a really good insight, I thought, into some of the key areas of innovation and some of the more nimble, agile innovators and what they're doing. Also, I thought Chet's fireside chat gave a good indication of how a company that wants to move fast is working. It's able to make its own air interface and develop its own hardware rapidly. But what I see happening is mainly it's first in the handset. That's the giant market, and power efficiency is key. So you see all the major semiconductors, the companies Qualcomm, Samsung, working very hard on power efficiency to be able to do millimeter wave RF transmissions with as much of the battery power going to the antenna. Also, there's interconnect and a lot of the circuit board on-chip antenna, some of the adaptive array implementation onto manufacturability and manufacturable circuit boards is a big effort, and that includes calibration, as we heard earlier. Some of the amazing things that 5G will offer, though, are being worked on by 3GPP, such as very, very accurate position location, the ability to bond channels both in Wi-Fi and millimeter wave spectrum will really give a huge turbo boost in enterprise, where you can imagine having 5G indoor millimeter wave combined with 60 gigahertz Wi-Fi. So you'll have really, really massive bandwidth channels available at very, very low cost points and very, very ubiquitous. And that really plays to what millimeter wave does, which, as someone mentioned earlier, is more of a capacity play than a coverage play. So if you're within a few hundred meters, you can look at both Wi-Fi and the licensed spectrum to give really massive bandwidth capabilities for applications we haven't seen yet. There are many, many other areas of applications. I'm sure the other panelists have some ideas.
Would anybody else like to weigh in on this area of sort of where some of the focus on innovation for millimeter wave? And I would invite Abhishek. I don't see you in my main panel, but I know you had planned to join this roundtable. I just don't see you in my main screen. But oh, there you are. Okay, great. So feel free to weigh in. So who wants to say a word? Do you want to start, Abhishek?
Yeah, absolutely. So I do agree with Ted in general. So on the terms of innovation, like being on the IC side, we think there's a huge role that the IC companies play in innovating the fundamental architectures that are needed to make millimeter wave 5G possible. And the two key metrics to keep in mind, like power efficiency and bringing the cost down while keeping the time to market quick, is very, very key. And so it's that's what we are working towards, and we have been delivering year over year. And it's really needed. The big challenge, and I'll leave it here, going from a traditional sub-6 to a millimeter wave phased array active antenna design is not a trivial task. It's a complete architecture change, and the innovation is needed not just in how these arrays are designed, but even how they are calibrated, how they are manufactured, even small nuances, and that requires innovation at every level. More importantly, at the IC level, that's what we are trying to deliver.
Any other panelists have a comment on this question?
Maybe I'll mention some of the interesting architectural things that are taking place, both in the current time as well as in release 16. I think there's some really interesting work going on around reduction of latency through architectural means, right? With the introduction of edge computing platforms and virtualization of the RAN, so that you can move much more of the processing to the endpoint of your network. There is also, I think, interesting work going on and coming more in release 16 around integrated access and backhaul IAB, where certainly we're seeing a lot of locations where the delay in getting deployment done is around fiber availability, right? And by introducing, as the industry will soon do, integrated access and backhaul technologies, we think there's a real place to accelerate deployments, get millimeter wave, especially to more places where it's been tough so far.
Okay, good. I wanted to shift to another question, which is to talk a little bit about indoor and the possible use cases in millimeter wave for indoor type applications. So far, the focus has been on outdoor, but with CBRS and private LTE and so on, and possible roadmap to 5G, I'd love to get folks' comments on millimeter wave indoors. And any volunteers to kick this one off? I'll take the first hand that I see. Anybody?
Yeah, I'll go ahead.
Andy. Oh, okay.
Yeah, is that all right, Mark? Yeah, I think indoor
great.
will be huge for 5G. It's a very wide pipe. There's already a good availability of fiber to most enterprise buildings, so it becomes another very broadband pipe available to every handset. And indoor, you can really build on some of the position, location, and geofencing concepts. And so applications in the cell phone of the future will be able to exploit the additional bandwidth from the existing Wi-Fi infrastructure plus the 5G licensed cellular infrastructure, if it's put into enterprises, to have wider pipes and then to be doing things with gathering data, censoring their environment. Basically, your phone will become almost like a radar, a sensory detector of where you are in the building, what the building architecture is, what your signal strength is. So you'll be able to do smart management of networks by feeding back where you are and what you're experiencing back for the performance in the indoor network. So it'll be like a self-healing kind of evolving network that manages itself with super accurate position, location, and very good signal detection capabilities. There'll be applications that we do with this wider bandwidth that people are working on and we don't know about yet, but it's really a new era because you're going from one 802.11ay Wi-Fi network in an enterprise to now whatever the enterprise network is, plus your cell phone, which also has 5G. And 5G is another several hundred megahertz of bandwidth and several gigabits per second data on top of what you're getting on Wi-Fi. So imagine these kinds of speeds to every cell phone inside.
Yeah, very powerful, very powerful. Andy, did you want to weigh in?
We're seeing a lot of talk from the large commercial portfolio owners in New York about deploying private networks. Most of what we're seeing, though, right now, of course, is they're looking to deploy private LTE networks on 3.5 that are migratable to a 5G network. That's primarily what we're seeing from our enterprise partners in New York.
Okay. Eve, have you been doing any work on in Europe on indoor type applications?
Yes, not so much until now, not specifically on the millimeter waves. If I may add, in fact, until now, what we have on when it comes to enterprise indoor coverage, what we have been deploying on services is Wi-Fi and also some Bluetooth low energy for positioning systems. And 5G in millimeter waves has the capability to replace all that. One additional argument in favor on 5G that we are also working on is the security for the enterprise, and that is a real argument to use 5G for indoor enterprise coverage and connecting the smartphones to the enterprise system. So that is just starting, but there is real potential on that.
Yeah, I guess I'll add. We've spoken with a number of large enterprises around 5G generally, right? They don't generally get into which spectrum they want to use, but fundamentally, the value of 5G to to a large warehouse or distribution center or a manufacturing facility, there are a number of pretty interesting use cases that really bubble up from their pain points. Where millimeter wave perhaps really fits into it is around video. And AR applications. And so, we've worked with, for example, our own manufacturing facilities, like the one in Austin, that want to improve production efficiency, want to improve kind of building security. And they want to put video kind of throughout the facility. And these facilities are, 9 to 10 football fields in size, right? So, there's really an opportunity. We think it will take some time, and I think some sort of partnerships and development of specific ecosystems that target some of these verticals, because the use cases and the requirements are quite unique based on their businesses.
Great. We have about 5 or 10 minutes left. I did have a question. What one would absolutely expect from somebody in the audience, which has to do, and I know nobody's specifically representing this part of the ecosystem on this panel, but I'm sure some of you would have thoughts on weighing in, which is with regard to handsets. We have seen a steady introduction of new handsets in millimeter wave. But what does the roadmap look like over the course of the next, let's call it, 6 to 12 months? Has there been a schedule shift due to COVID? Of course, particularly for the North America market, a big question is Apple, and will there be millimeter wave in the anticipated fall iPhone introduction? That's a big question. Nobody knows the specific answer to that, but I'd love to just get a quick handset picture from somebody who'd like to weigh in. I didn't earmark anybody specifically for this, so anybody want to jump in?
Maybe I'd be the right person to start, and I'll note that I'm not part of our device group, but can speak to it a little bit. There are Samsung now offers 11 5G handsets around the world. Many of them are available in the US, and most of them support millimeter wave. And so, starting from the Galaxy S10 5G and through to the S20 family and whatever's to come in this fall, we're seeing quite a lot of millimeter wave support throughout that portfolio. And the other important step, you talked about kind of innovation and steps going on in 5G. We're starting to see more and more that 5G support is sort of democratizing, we call it, right? Moving down the portfolio into mid-tier devices that maybe hadn't had it before. And I think you'll find that even in that mid tier, a number of those devices will support millimeter wave.
Anybody else have any comments on the device front? No? Okay. I'm going to actually move to another question from the audience. This is specifically for Zenfi. How do you handle existing underground infrastructure that may be crowding out your new infrastructure needs?
So there is a finite amount of underground infrastructure to support the cabling. This is driving a big problem. The inefficiency of CPRI, along with the large amount of bandwidth being created by millimeter and other bands, is right now the way the carriers are solving for the front haul transport is just to use a lot of fiber and one channel on each one. This is something that has to change. When you were talking about the technology earlier and innovation, I don't know if we really need to innovate, but we need to implement technologies to drive more fiber efficiency, because this question is very apropos, and it's a real problem, right? There's in New York, in Manhattan, you have the ECS conduit system. It's very congested. It's very difficult to work in. When you open a manhole, there might be there's lots and lots of splice cases, and guys are crawling all over it and damaging the fiber. So, space to deploy cabling is finite. And so we have to be more efficient in the use of the cable.
Okay. Another audience question, again, one that we would predict, but I think it's important to get into this. Specifically for Ted, in the NYU wireless study of millimeter wave technology, has there been interest or action on the study of millimeter wave RF safety issues? I know personally I probably get one press question a week at least on this. I'm sure you get more. So what are you seeing there?
Yeah, I do get that question a lot. And as we were ramping up NYU wireless and saw that millimeter wave could work really remarkably well, I worked with colleagues at the NYU Medical School, where I also have an appointment in radiology. And we did a very comprehensive literature search and studied what we knew and wrote a paper that actually the National Institutes of Health made as a public document. And you could Google it. If you just Google wireless safety for generations to come, just Google wireless safety for generations to come, you'll see that paper. The federal government made it open source. That was, I think, 2015. The bottom line is every bit of evidence we could find shows that the only danger, the RF safety danger at millimeter wave frequencies, is due to thermal heating. If you heat tissue, thermal tissue in human beings or animals over several degrees centigrade, say 10 degrees centigrade above nominal temperature, you start to damage cells. And whenever you damage cells, you damage DNA, and that could lead to unstable cell growth. So really, RF heating is the only thing we could find in the literature for over decades up to the high millimeter wave frequencies. It's important to realize that millimeter wave frequencies are 4 orders of magnitude, 10 to the 4th, 10,000 times lower than the frequencies of ionizing radiation, ultraviolet, X-ray, and gamma rays. Those ionizing radiation frequencies are where it is known that there's enough energy in the RF radiation to knock electrons out of a stable valence shell. And when you have unstable atoms, you have free radicals, and these combine and can create abnormal cell growth. That's the issue with ionizing radiation, which is known to have health effects. So what I tell people is that you better wear sunscreen and worry about how many flights you take in an airplane above 10,000 feet than you should about 5G wireless, which is 4 orders of magnitude in frequency below the frequencies where ionizing radiation happens. The reason why I say sunscreen is because ultraviolet rays are the beginning of the, above optical, is the beginning of the ionizing radiation frequencies, which can cause unstable atoms. And X-rays and gamma rays and galactic radiation are what we are exposed to when we fly above 10,000 feet and get out of the troposphere. and we're exposed to the galactic radiation from the sun and the stars in the universe. In fact, if you Google, you'll see that NASA spent a lot of energy studying the major dangers for flying humans to Mars. And the biggest risk was viewed as the galactic radiation, which humans would be exposed to for the many, many months in space where we're not protected by the troposphere. So it's these ionizing waves that you need to worry about. And I even talk about this in a paper we wrote last year about 6G. If you Google 6G opportunities and challenges, I have a whole number of paragraphs about this issue and a lot of literature that's been published. So at millimeter wave, I say it's, for everything I know, is it's safe simply because we're so far below the frequency range at which radiation is known to become ionizing.
So for all of those of us who get these questions at from the media and in the industry, but also from friends at cocktail parties, at least when we used to be able to go to those, we could just sort of press play on that answer, I guess, would be great. Any other folks want to weigh in on that? Have a comment on the millimeter wave safety? Okay, I'm going to take moderator's prerogative here and go with one more question. It's a little bit more specific, but I think it's a good question, so we'll get to it. One of the difficulties to roll out massive small cell networks in 4G and LTE was the significant sort of O&M issues, and I'm wondering whether millimeter wave 5G makes this sort of concretely simpler. And of course, that's all mixed with issues of Open RAN and virtual, all the other trends that we're seeing. But there's maybe just like 1 or 2 quick minutes on this question. Who would like to weigh in? Maybe Abhishek, do you have a thought on that?
Yeah, absolutely. So I think we kind of covered that in the presentation, but from a technical perspective, or technology perspective, the biggest challenge is just the whole active antenna or phased array architecture. That's a new thing for a lot of OEMs, a lot of the market, and that too working in millimeter wave. So it's not incremental change. So just having the skill set and the experience to build those radios with active antennas, plus using the right kind of components or beamformer ICs that work. So that is a very important choice. And I think that's where our recommendation is go with the physics that works, go with the ICs that work and have a proven history. That's the technical side. On the commercial side, the big challenge is the cost and the time to market. So we have to address those two. If this 5G deployment takes years or decades, the ROI is not going to be justifiable enough for the operators. So time to market has to be quick. So use the things that are already being used in the market, have been proven to work, and the cost. So again, as I said in the presentation, the CMOS-based IC bring the cost down, bringing the handset IC technology into the infrastructure world. So cost, time to market, and just understanding the phased array architecture, how that can be implemented on a mass commercial scale, are the biggest challenges or that we have to overcome as an industry to make millimeter wave 5G possible, in my view.
Okay. Anybody else? Alok, did you have a thought on that?
No.
Okay, sorry,
I think,
Eve.
Was it Eve?
Yeah.
Okay, saw Eve raise his hand.
From our perspective, yes, there were different roadblocks on large-scale small cells deployment. And there was one that we already addressed, that was the permits and the administrative process to deploy sites. And also one question was how to operate if we multiply by 10 the number of cell sites, basically, that we have in our networks. And the answer is not specifically coming with 5G, but what we needed that was not available some years ago, which is now available, is the automated networks. Like, for example, what we call the self-organizing networks. So the networks that do self-healing, self-configuration, and that is the type of thing that was not available some years ago, which is now available and solve some of the O&M issues that we had with the small cells. So we have some answers now. They are not specifically linked to 5G, but they are now available so that we can really reduce the cost of operating small cells.
Okay. Great. Well, I think we'll have to close it out on that. We're a little over the time. So first of all, I'd like to just thank all the panelists for joining. I thought we covered a lot of ground in 50 minutes, and you're all the people who are helping make this happen. We've got a lot of the real innovators in millimeter wave on this session. So thanks for participating. And I'd also like to do a quick shout out to the folks at Fierce Wireless for putting together this 5G Blitz Week. The previous couple of days of sessions have been really good. I've got 2 more days, and I'm finding this is filling a very needed gap. And since there haven't been the conferences, there was no MWC. There is not going to be at least a live MWC LA and other events that have been had to be canceled. This has just been a lot of wonderful content, and we've had a really great list of speakers. So thank you to the panelists. Thank you to the folks at Fierce. I'll hand it back to Kevin.
Great. Thank you so much for the kind words there, Mark. And thanks to all of our speakers. Thanks to everybody for attending the third day of 5G Blitz Week Summer. On behalf of Fierce Wireless, I'd like to thank all those speakers for participating today again, as well as our sponsors for today, including Anoki Wave, Samsung, and Zenfi Networks. Please join us back here at 11 a.m. Eastern Time tomorrow morning. Our next session is going to be Beyond the Cities. What does next-gen wireless look like for rural areas? You can see the schedule here below, but we're going to have speakers from the FCC, Pioneer Cellular, Intel, WWT, Worldwide Technologies, CCA, Intelsat, and Inseego. So thanks again, and take care until then. We hope to see you tomorrow.